Icy Dock manufactures a plethora of drive enclosures. Today we're going to take a look at a flexiDOCK docking enclosure. So as we examine the what, why, and how, we'll do an unboxing on this, and we'll examine the requirements. First, the what and the why. It's part of our, when you build a computer and it's purpose built, we're driven by data. So the data that we're driven by are 2.5-inch SATA drives. For an example, right now my workflow is I use an Icy Dock device that allows me to take a 2.5-inch drive, put it in this enclosure, so that I can then insert this into a hot swap rack for 5.25 drives. Now, ideally the kind of rack I'd like is because of the recorder. You know, we don't always choose the media we use, but we choose the recorder. And our master recorder is an SSD recorder. It uses 2 disks. So what we're looking at with this Icy Dock enclosure with a flexiDOCK, this is for 4 2.5-inch drives in one 5.25-inch drive bay. So we're going to put this in the case, and this goes to workflow because normally we have 2. Now, because this is purpose built, if we had a recorder on each one of the cameras, then that would multiply how many SSDs and how many of these kind of racks we need access to. Okay, we have a separate video about cases for XL ATX cases, and that was one of the requirements. We need drive bays for drive bay devices like this. Because we're data driven, we need access to our media. And because we use SSDs, and I never would have thought when we started using SSDs, well, we would consider these as removable media. But this is what we use. This is the recording format. Now, this is a Blackmagic SSD rack mount recorder, and I'll put a picture up and give you some links in the description, and I'll also give you the part number on the part we're getting ready to look at. The point of this is there's 2 ways we use media. 1, access, and 2, storage. So because we have the ability for 4 bays on this particular rack, that means that all 4 bays don't necessarily have to be configured to be used for active storage. What do I mean by that? Well, for example, as we look at the requirements for this, because it requires one 5.25-inch bay and we have access to 4 drives, this is a perfect example for a hot swap rack. And when we're talking hot swap, that also means the BIOS has to support it. So we'll go in and take a look at that, and I'll give you my 2 cents on that. Anyway, there's a couple of styles of racks. I prefer a rack, and I'll get into that as we do this, that when I stick a drive in for, say, a 3.5-inch drive, a 3.5-inch drive may be in a computer for a month, 6 months, or a year. And I have internal and external drives of 3.5-inch for those kind of purposes. Okay, when I go to the 2.5-inch drives that go into this rack and then go into another rack, the purpose is to eliminate this. These work, they're great, but I'd like to get this simplified where I go from the recorder straight to the computer where we're doing the editing, the edit bay. And a rack like this is nice. Now there's 2 ways to look at this. I like a rack that gives me the ability to do storage, but I also like a rack that has like a door on the front, like a latch for the intended purpose, because I have short-term media and long-term media. So I like a rack that will fit in a space to do both. Now, Icy Dock does make a device that will do 3 drives. It'll take 2 2.5-inch drives, and then it has space in the bottom for 1 3.5-inch drive. But the way that rack is set up, and I'll put a link to it, it's just like this, where it's not set up to have a latch, to have a door behind it. And for a 3.5-inch drive, I want the ability when I put that drive in to have some kind of door over it, so it's like, okay, it's there, leave it alone, don't touch it. Even though it might be on hot swap, and I'll get to that. So what is it? A removable rack. Why? Because we need access to our media. And how? Let's take a look at the back, the business end. And we have 4 SATA ports, and we have a power adapter in the middle. So that one power tap takes care of all these, and that is a SATA power tap, not a Molex, which I like. Now the electronics in here, there's a PCB, and what we pretty much have in this configuration, which is different than the previous video, is there's no bridge chip. So the electronics in this, all this is a passive backplane, meaning it allows us to connect media on one side, which is temporary, and it connects the connectors on the back side, which are permanent. So the media comes in and out, but there's no fiddling with cables. When we insert it, eject it, We don't have to worry about that. So I like the simplicity of this. Again, this is some server technology that's trickled down to the desktop. So what we're going to do is take a look at this, examine it. We're going to install it. And real quickly, what I want to do, because it's more about a test of the drive, is we'll run our heat and speed test. We'll get that up on the screen. But the other test I want to start doing is the actual throughput, because SATA 3 is 600 megabytes. So these will top out at about 500 megabytes. Now, there's no bridge chip, so I don't have to worry about any kind of interface, as in the previous video, to reiterate, of going from one interface to the other interface. This is straight SATA. That's a benefit. And the drive bay, we're going to go in right here in this empty slot. On one more thing I wanted to mention about the workflow, as we look at the connections on the back, number one, we can insert 4 drives in here. But just because we can insert 4 drives, my workflow is either, as I look at this rack, meaning for my workflow, if I'm working left to right, then my 2 top drives would be my active drives. And if I was working top to bottom, then my 2 left drives would be my working drives, which means the other 2 drives are not working drives. And why is that important? Okay, how many SATA ports do you have on your computer? We've got 8, because I'm going to use this on the Gigabyte TRX40 Designare. Now, even though I have 8 SATA ports, 10 years ago SATA ports were a big deal. They're not as big a deal now. All I really need is about maybe 6 at the most. I'm going to have 4 ports that I want to keep for, well, we'll look at the front of this. First of all, this case gives us 3 drive bays. So we have a Blu-ray, the open bay that we're getting ready to use, and then this bay already has a dual drive device plus a couple of USB 3 ports on it. Okay, what I would like to do, because of the situation with cases, utilize a case where I have access to at least 2 drive bays. And the reason I want to show you that is relevant because I'm only going to use 2 cables. So that means I have 2 drives that can be active, but I have a location for storage. For example, how and where do you store these? I've been storing these drives in these cases, and I put them in the anti-static bag. Then I set them aside till I'm ready to use them again. I take them out of this rack, put them back in. That brings up another point. Because this is used as removable media, I format it in the device it's going to be used in. In other words, I don't format these on the computer. I format these in the SSD recorder. So any removable media, as a side note, whether it's for a camera that uses an SD card or a recorder that uses an SSD, format the media in the device that's doing the recording only. And always, always, to maintain file structure and integrity of the consistency of those files, every time you pull that disk out and move that media, when it goes back to the recorder, reformat it. It keeps the data structure fresh, because the data structure in fresh, you're able to maintain integrity of the file structure. Now, another issue is if you got multiple cameras, SD card's a good example. Sometimes you'll get drift, and you will have less likely a chance of drift by reformatting the media. So, enough of that. Let's get our rack installed. Not all cases lend themselves well to doing what we're going to do. And the reason I say that, I'm going to show you in this case on the inside right quick. It's got those quick release latches. Okay, anytime I'm using a rack where I'm plugging something in, I'm got that force in and out, I don't want those little clips that will hold on to the device, like say you touch a Blu-ray disc, you touch that button, the disc comes out, goes back in. Okay, that's no big deal. This, there's going to be some force, so that force going back, I want to be able to set screws to it. And on this drive bay device, I've got these quick latches, so I want to be able to get at least 1 screw in here so I can tighten that device down. But I've also got to pull the lid on the other side, so again I can get screws on the other side. These were a good idea in the beginning, but when you're using hot swap racks, those become a problem. They get in the way, because even though I remove them because I'm changing stuff in and out, I still need to use the screws so that I can test the integrity of the device I'm plugging into. Let's get this mounted. Right quick, before I install this, you can see the way the top, as we look at this, let me turn it so that you're seeing top to bottom. This is the bottom, this is the top. Now this enclosure is metal and plastic. The what looks like a heat sink on top, that's plastic. The metal is the sides and the base. So there's not really a heat sink in it. And of course you can see the passive backplane, the PCB that's inside. So we're going to mount this right over here in this drive bay. We'll tilt that just a little bit so you can get a better view of it. Now, due to the depth of the device, you can see this other device here we've got. It's a full drive bay device deep, as well as the Blu-ray burner. But this device is so short, I cannot reach the rear screws in this rack. So this clip is a bit of a consternation. That clip's got to come off if I'm going to put screws on this side to secure this device, because the device showing that red dot on the end of that screwdriver, that's the end of that device right there. So I need to be able to access those front screws, which I cannot. So I've got to be able to put at least 2 screws on the other side, which means I've got to flip this up, get the other lid off so I can do that. I just want to point that out. So for those of you that, in all cases right now, that have drive bay devices, and most cases don't, because most cases now are more about form over function. We're always about function number one. This is another reason to go to a rack mount case, so we still maintain function. The problem with rack mount cases is the 80mm fans. We need 120mm fans. And for those of you that have been able to make an HTP case work for you, fantastic. XL ATX case, you go down the line of priorities, change one thing, changes everything. So I just want to point that out. It's shallow. You've got to get access to those front screws. If you don't, a little more work to get it installed, which is what we're going to do. Okay, case is flipped over. Now I'm on the other side. I want to see if I can show you a close-up why we had to flip this over. Okay, now we're looking at the other side of the case. I'll get on that as close as I can. And this shows a good example of how this only sticks out a little bit. In other words, we're not full depth. So that's the one screw hole that we're going to have access to, since we cannot use the rear screw hole because of the depth of the device. And yes, screws are included, little manual. No SATA cables though, which is kind of a bummer, but understandable. I want to point that out because it's easy to miss something when you're trying to install something. And then you go, oops, I got to have something else. But motherboards all include cables. Now, the Gigabyte TRX40 Designare only had 4 cables out of 8 ports. They're not all hooked up. We happen to have extra SATA cables. But if you don't, that's something you might need to look into. And for those wondering, these are short and fine thread screws. Put a light on that so you can see it. I can get that one little screw in there, and we'll have that device secured. It has got to be secured in the case, because when you think about it, the amount of force, you know, we've got to be able to plug that in and unplug it. That's one thing I like about internal media. With external media, it's not being lazy, it's just workflow. But you got to hold the device and the media to plug and unplug. That's an advantage of rack mount devices. You might put one hand to steady yourself on the rack and another hand to pull the media in and out. It's just workflow. But I thought I'd point that out. So now I got to flip the case over to the other side so we can get the screw in on the other side. Now that I have this secured, I'll put the lid back on. I want to thank Icy Dock for making this video possible. They sent us the device today that we're looking at. Thank you. It's amazing how heavy computers get when you start loading them up and putting all the stuff in them. Okay, due to the positions of the cameras, I'm going to lay the case back down because even though you can see how this is going to set upright, it'll be easier for me to get a close-in if it's laying down on its side based on the way I've got the cameras all set up. So I want to explain all that. Musical chairs. This is one of the very few times I have the front lid, or the lid with the clear panel on the case. But with all the moving around and flipping, I didn't want anything pressing on the equipment inside. Point that out. Okay, now we're back in position on the case. So this latch that's supposed to be advantageous is a problem getting in the way, and I've got to pop it loose. So once I remove this latch, it's toast. But I need access to those screw holes, so it is what it is. Well, that wasn't riveted on. As you can see, what I thought were rivets, just little plastic pins that stick out. So all we had to do was take these 2 tabs and widen them just a tad bit with a straight blade screwdriver, pop that latch out. So latch is still intact. It still works. If I choose to use it later, I won't. But now I have access to those 2 screw holes at the front of the case, which are those 2 holes right there. And here's the end of the device right here. So those are crucial for me. So I'm holding on with 1 screw on one side, and I'll have 2 screws on this side. That should be enough. But I wanted to point that out. And there were also 2 extra screws included in the pouch. Installation's complete. Now all we have to do is get back in there on the business end and plug in our cables. Before mounting the device, which is going to go in like this, I'm going to suggest, because it's shallow in depth, plug in your cables on the outside of the case, because once you get this situated in the case, there won't be any room to move around unless you can get your hand up in there. So we need to plug in a power cable, and we need to plug in data cables, of which we're going to put on 2. And to make this easy to see, I'm going to use some special, these are by SilverStone. We found in the past, when we're using SATA drives and hot swap racks, just testing on a fluke, we found we had better luck with these cables than when using the standard cables that come with the motherboards. Now, I think the cables that come with the motherboards look like a better quality, but it's SATA. And in the testing we did on a fluke, we found we had better luck with these. I'll get a link up in the description. I believe they come in black, they come in white. I'm not sure if they come in red, but I like the white ones. It makes it easy to see what's going on, especially doing a presentation like this. And these have the straight connectors, which I appreciate. I don't like those angled ones. And no, these do not have a latch on them. I have pros and cons about those latches. If you've ever had a cable that had a latch and you miss that latch and you pull it, well, then you know what happens to the latch. You risk breaking that locking mechanism if you forget to press down on that latch before you remove. So to reiterate, these don't have a latch on them. So there's always pros and cons to everything. And since we have 8 SATA ports, we have plenty of ports. To reiterate, we're not using all of them. And the 2 I happen to be using are right under the GPU. But I can feel my way and insert them. And I'm only going to use 2 because that's the purpose of how I want to use this rack. To reiterate, 2 drives will be active, then the other 2 bays will be for storage. And it's just a matter of whether it's left or right or top to bottom. The only thing that's giving me grief is the SATA power tap. I have the tap in the case. The problem is getting it out to the front. It's positioned with the other cables for a 5¼ inch device based on depth. Based on the depth of this, I'm having a bit of a difficulty getting to it. So what I may have to do is push this deeper in to get to the cable and then pull it back out. But I've got my SATA cables routed where I can get to them. That looks good. Now I just got to push it in, push it to the back so we can get to this power tap. I don't like setting up a case or a computer with everything all tied down so with the cables because we pop stuff in and out. But we had so many, whatever you want to call them, making comments about how messy things were in some of the cases. It's either show a case empty or if it's got stuff in it, everything's got to be tied down, which makes extra work. So that was the extra work I had to go through. The cable was there. It's just the lead was not long enough to go in. So I'll point that out. So just a little further, which is kind of ironic because now I got to remove the SATA cables so I can get that SATA power plugged in. Okay, SATA power is plugged in. Now we'll get our 2 data cables plugged in. Now that we have our connections complete, we need to take this back down and get the drive in position to the front of the case. Funny how changing one thing changes everything. And again, we have our front screw holes lined up. You can see right there. And on the back side of the case, we've only got 1 screw hole. There's a grommet here that we've got wires tied down to, but there's not another screw hole behind there. It'd be nice, but there's just not. The top bay has it. The bottom bay does not. So work with what we've got. I point that out because you want to make sure your case can accommodate, first of all, that you have a 5¼ inch bay. Second of all, that you have access to the screw holes. Because if you don't, you can't use this device. I wouldn't use it in a slot that has those latches because you've got to be able to insert. And putting pressure on that, eventually you might push that drive in and you've got that to deal with. Okay. And right quick, while I've got this back side off, I'll show you. This is the SATA that's been allocated for these 3 devices. But that cable, the way it's wired down right now to keep everything tight, I had to pull a little bit to get it up so we could extend and hit that device. It was allocated to only sit to a device back here, not up here. Just one of those little details. Lid's secure. Let's flip this back over, get this thing powered up, go into the BIOS, set our hot swap, and then let's go to Windows and see how this thing works and run our 2 tests. We're ready now to see how well this works for us. Kind of ironic going from one Icy Dock enclosure to another. Let's see how this does. So first thing we want to do is get powered up. Let's go into the BIOS. We'll go to Settings, I/O ports, right down here, SATA configuration, enter, and right there, hot swap, chipset SATA port, hot plug, auto or disabled, no in between. On a side note, used to we had the ability to individually set these ports, and Gigabyte, in their infinite wisdom on the X399, turned this feature off. Okay, on the WRX80 they brought that feature back, but when they brought it back, we can no longer set individual ports. There's some ports, like if I've got an internal drive. For example, this is an internal drive. I'd rather this not be able to be set hot swap. So why do I bring this up? Well, some ports I want hot swap, some ports I don't. If it's an internal drive, I don't want that set for hot swap. I don't always have to be thinking about who's on first. So this is a global setting. We're no longer able to set these ports individually. It's auto or nothing. So that's turned on. So we'll do F10, save configuration. The computer will reboot. This time we'll go past the BIOS, we'll go straight into Windows, and so we can see how well this works. Remember, it's all about your data flow. Having access to our media, and our removable media is a 2.5-inch drive. And we wanted to show this as an example, comparing, as we mentioned in the last video, external media versus internal media. And because this is a straight through SATA swap, there's no bridge chip, there's no reduction in speed. Now, even though this is SATA 3 6 gigabit, which is about 600 megabytes, that's burst mode. That's what we'll see when we run the test for heat and speed. However, when we actually do the data throughput test, I expect, since this is a straight connection, we should be about 500 megabytes tops, which is good. I think the best way to show this, we're going to bring up picture-in-picture in the top right corner. So when we plug that disk in, you'll be able to see. Now what I may do is on the computer screen, down on the bottom right, zoom in so you can see where that becomes available to show the hot swap, hot plug, and identify the disk, for an example. Now when I plug this in, remember we are left-right. So on the left, top to bottom, these two are active. On the right, these two are not active. These two will be used for storage. But if I wanted all four of them active, I plug in 4 cables. So we're going to plug this disk in, and when I insert this, and also a screen will pop up with an active disk window. Bingo, there it is, read the disk. Okay, the screen on the bottom didn't pop up, but the other window popped up. So I'm going to zoom in down here on the bottom right real quick. Let's take a look to remove hardware, and there's our disk. SanDisk SSD H3 500 gig, disk fat D. And that is this disk. There's 3 files on here. These 2 files are the files that are recorded, and the recorder will give these numbers in succession, or in sequence. And then this 3rd file is the edited file. What I want to do is copy that 1 file, which is a little over 10 gigs by itself, and I'll copy these 2 files, which are a little over 92 gigs, and this will be the throughput test so we can see how long it takes for a file of that size to copy over. Now I'm going to copy these files which are on the disk, which is SATA 3. SATA 3 6 gigabit is 600 megabytes, and I expect to reiterate that I top out about 500 megabytes. We're going from a SATA 3 SSD of 600 megabytes to an M.2 NVMe drive, and I believe the boot drive in here is a Sabrent 4 terabyte because this was set up for instruments. So we're looking at PCI Express 4.0 first generation. So the big influence is going to be the lowest common denominator, which is this SSD, but we use SSDs because of the recorder, and I'll put some information up about the recorders. Now, the new version of the recorders I want to interject from Blackmagic can record in 2 formats. One, an SSD, which would be 2 SSDs, and number 3, it can also record to an SD card, which brings up new opportunities because we need some way to get access to that media, and not some of this junk they sell with all this garbage ports on it. And most of all the good ones are some kind of an external device that we may get into later. But right now we're working on Icy Dock to see how well we can get these SSDs in and out. Let's take a look at this. First of all, I'm going to create a directory based on that name so I can keep this material separate. And that's the directory we're going to. So on the source disk, which is the SSD right here, and you notice we've got a light, we're going to copy that media over. Let's see how long it takes. First, the edited file, copy. Alt-Tab, right-click, paste. And let's watch the scale. And this should top out 489, 490. We might get to 500 megabytes. Okay, just under 500 megabytes. You can see how long that takes. Now I'll go back with the 2 files that are unedited and see how long they take. And these are the throughput tests. I'm going to use some old terminology you've probably never heard, but referring to a 0 as aught, that would be capture 4 aught and capture 3 aught 1. So we'll take those 2 files, copy, and all 3 of them now will be on the disk. So I'll right-click, paste. Let's see how long these 2 files take to copy to that C drive. Let's zoom in on that, and we're topping out at 499 megabytes. Now that first file that I copied that was not quite 11 gigs, but a little over 10 gigs, as opposed to these two files. And that first file was an MP4 edited. These two files, I believe, are MOV files, and they each have space in the file for 16 tracks of audio, because the capture files are recorded in SDI, and that's what I edit, is SDI files that have the potential for 16 tracks of audio, even though we only record in stereo like what you hear me talking right now. And I want to leave this screen up while I'm talking so you can see where we top out. 499 megabytes. So that's pretty good, 500 megabytes. A little bit of overhead because of SATA, but considering burst mode versus actual throughput. Now when we're through with this, I'll go back and I'll run the test, heat and speed, where we have the two screens up, and we'll see what kind of numbers we get. And that should be fairly quick. But this is something we need to start thinking about and remembering when we're talking about throughput. For example, when we talk about specs, that's not throughput. That's burst mode. You have to keep that in mind. Some perception and perspective on the situation. Now this says this is going to take about a minute, so probably from the start to finish a couple of minutes for this to run over. Now to reiterate, remember this is all about the media because we are data driven. We do not choose the media, we choose the recorder. And whatever media the recorder uses, that's what we have to embrace. So since we're using SATA, we've got to figure out how to expedite. And that's what this rack is about. 4 drives. 2 that we can use for data transfer, and 2 that we can use in that drive bay for storage. And that's something to think about. How do you store your media? Where? Now with SD card, you know, we've got cases we can put them in. But I think it's kind of ridiculous to buy cases to put SSD drives in. That's why we've used the Icy Dock metal enclosures. 95% complete, 10 seconds left. Not bad. I like to watch the process to see what we're doing. Done. Okay, that was fascinating. Now, let's get the screens up where we can do our heat and speed test and see what those numbers get for us. We're going to see something completely different. But what? Let's find out. First thing we'll do is bring up hardware info. We're looking at sensors only. Let's scroll down and find our device. Smart technology on the boot drive, which is a Seagate FireCuda 520, and that's an M.2 NVMe SSD, to reiterate, first generation, capable of about 5,000 megabytes. And we're going to be testing an SSD. And for those wondering about the brand of the drive, I'll interject, Blackmagic has a list for their SSD recorders of the drives they specify. In other words, not all SSDs are alike. Just because they have a spec with a throughput that they are SATA 3 does not mean they can handle the constant throughput for the data. And Blackmagic has a list of drives they've tested. We stick with that list. That's why we're using these particular drives. It was the best drive we could find for the price at the time. Always bang for the buck and still achieve the throughput that we require. Now, we're not pushing the limits because of the file size and the codec we're using, but I want to interject that. So there's one piece of information on the SanDisk. We've got to scroll back up just above the Smart on the Seagate, and here's the Smart on the SanDisk, 500 gig drive, and it shows the drive temperature, so we'll see the thermistor, and that's what we're looking at. So we'll highlight, and we're looking at the current, minimum, maximum, and right now the current is at 38 degrees, and the maximum is 42 degrees centigrade. So let's bring up Crystal Disk Mark, and the version we're using, because somebody will ask, is Crystal Disk Mark 7 64. This is the version we've been using with all the tests. Yes, we need to update it, but we haven't because we want to keep a baseline. So we'll bring up our dual screen, and this is D drive, and because this is a 500 gig disk, we'll go to a 512 megabyte test size, all. Now I'd love to zoom in on this, I'll highlight, but since we're trying to watch heat and speed, I'll leave this like it is and let it run its course. And the test is complete and you can see the results. Not bad. On the read, just under 550 megabytes. On the write, just under 500 megabytes. And on the heat, we top out at 46 degrees. Heat is not that big a deal on a SATA, but in case somebody asks, that's the numbers, there it's at. So what we've achieved is we've been able to take and simplify our workflow. Instead of taking out of the SSD recorder, putting it in an Icy Dock and then into another rack that could be an Icy Dock, then read the data, we're going straight into one Icy Dock. So we've eliminated this step. Now this is the way we used to store them. Now we store them in the computer. 2 bays active, 2 bays for storage. One other thing I want to show you on this is removal of the disk. We'll bring up the screen. We've got the open window. We'll do picture in picture. And if you'll notice, we have disk light activity. And there we are, close up, where you can see arrow down for the bottom, arrow up for the top. And the same thing corresponding on the right side. We've got these two set active and these two set just for storage. So all we have to do is remove the disk, light will go out, voila. And yes, if I put this on the right side, there's still power to the device, so it's not actually storage like I'd like. And those have a snug fit when they go in and out. So when I set that, I can just set it there. I don't have to plug it all the way into the contacts, to the connector. If I insert that all the way, then yes, those contacts will be active, and yes, there's power. So it's just sitting there for storage. It's tight enough, it's not going to fall out. It holds real good on the sides. So I wanted to point that out. And that's a SanDisk. So I hope that helps. I want to thank you guys for watching. This is BuildOrBuy. My name's Gil Boyd. Welcome. We look forward to seeing you next video. We're out.